So why don't you quickly introduce yourself for the audience?
Yeah, absolutely. My name is Deniz. I'm a member of technical staff at Amazon AGI SF Lab, and I do a lot of work in web agents.
That's exciting. And tell me about, is there a particular piece of research that you're presenting at NeurIPS?
So I'm not presenting research at NeurIPS. I'm just here as nerd, just spending time with researchers as much as possible, and then meeting cool people to bring onto our lab.
Yeah. What are some of the things that you've been most interested to learn about, or best posters you've seen, best sessions you've been to?
I think there's a lot of great people that are thinking about similar things when it comes to reinforcement learning. Everyone talking about the difficulty of, sparse words, trying to train on unreliable sort of like environments and there being a lot of noise. So being able to connect with researchers and be able to say, oh, that same frustration that you have, it's manifested in us in this way, and be able to share sort of like common expertise has been very enjoyable. It almost sort of like reinforces again how much of a community this is, and that's just like a part of these conferences that I adore.
So what do you mean when you say unreliable environments? Tell me about that.
That's a good question. So when it comes time to academic research and then industry research, with reinforcement learning, when people are trying to create RL environments, they are not always, as you increase the complexity of your environments, I would say that more things could go wrong with those environments. There's more edge cases in those environments. So being able to see how people think about RL environments in code and the difficulties of creating like really good ones has like stood out to me in my conversations with researchers.
Totally. Yeah, it does feel like everybody is talking about RL environments right now. Do you think that there's anything that gets lost in all that hype?
That's a good question. I'm not sure if anything is lost in that hype, other than to say that quality is a lot more important in RL environments than you think. Having something like 90% there is not the same as like something that's very high fidelity. In our use cases, right, we're using large-scale reinforcement learning for web agents. What that means is we have hundreds of gyms and orders of magnitudes more tasks. And by training on those, we see that we're able to generalize and increase reliability in unseen environments. That is actually the core insight that allowed us to refresh our Nova Act model released yesterday and be #1 on several benchmarks, which is like really exciting. But in that context, all throughout our training, we observe time and time again that it's very important to have really detailed, good environments. It's not enough to mock a website 80% and it to miss a lot of features, right? You need detail to be able to allow the model to really explore. If there's like unclickable buttons in your website and your agent tries to click on that and sees a no reaction, that might teach the model something different than what you're intending to. So quality for us is very important, and I assume quality is actually the one thing that gets lost in a lot of these transactions, like a lot of these conversations, and it's one of the first questions that I ask a vendor if they're trying to sell me on their RL environment.
That makes sense. So like it might look like a particular environment is 80% complete, but if you train with that, you're actually getting way less than 80% performance.
I would say that if it's incomplete, it's risky. Like you ask the agent to do a task. It tries to click on a button that it's unclickable because that feature is not built. That is just like noise. That is causing problems with models exploration. What if in a fully rendered website, that button would have still led to the same good behavior? Look, I understand that from the perspective of the vendors that is building these websites, they say 80% is enough to do X, Y, and Z workflows. And that is a totally fair thing to say. However, in reinforcement learning, you effectively allow your model to explore. So if your model thinks that there's a different path and it tries to click on a button that doesn't exist, that feature is not built, it might unnecessarily make your model overfit to only a small, narrow like way of doing that task. So yeah, high quality environments is very important for us, especially when your temperature is high in training and you do a lot of exploration.
That makes sense. So congrats on the launch yesterday.
Thank you.
And tell me more about the Nova Act model.
It's been insane. And by the way, like as a researcher, seeing your work demoed on reInvent on stage is like a crazy feeling of just like, you know, someone trying to explain to a massive audience and try to explain in a way that everyone can understand. The model is significantly more cost effective than the other models out there. And the way that we've designed Nova Act, it's always been with enterprise prototyping in mind. The thing that sets us apart is instead of requiring the user or the programmer to stand up a VM or anything like that to develop computer use capabilities, we have a beautifully packaged SDK that allows developers to create a web agent in just 3 lines of code. And that is insanely powerful. We have enterprise customers right now, like Hertz, like Automation Everywhere, a bunch of others, that have been using us to sort of like automate workflows, and it's great to see so far. Another really interesting thing about our RL work, and something that we underlined in reInvent, was how important to realize that agents are not models, they're stacks. Like an agent comes with its tools that it uses to interact with the environment. And it's very important how you train them. In our use case, our agents is the combination of a model, an orchestrator, which coordinates the model, and the actuation stack, which takes the actions that the model produces and basically executes them on the browser. These are tools that the model has access to. The way that we got to the performance that we had was to have an RL system that trains all of these together in one. It's very important for your RL to use basically the same stack that's going to be deployed in production. That's the only way you can ship what you train. So that was also something that's very important and very near and dear to my heart.
Yeah, that's fascinating. I think that the stack, not a model framing is really helpful. When you play this work, 3 years down the line, and you imagine agents becoming much more mature, in use everywhere, like paint a picture of what that world looks like and what you're excited about. Like, what are the implications for people, for how we use the internet, for what technology looks like?
Yeah, this is a great question. When I think about my work, I see like 2 different modes. One mode is to realize that web agents can become the API when APIs do not exist. Web agents can basically be an endpoint that you call and you expect it to do some behaviors just like an API, but you don't know how to involve yourself with what happens in the background. So a programmer that wants to build a connection between 2 websites that do not have a connection at the moment can now use a web agent as an API to be able to go ahead and execute that. So mode 1 is like connective tissue. Connective tissue that can run in the background, similar to how an API exists today. Mode 2 is sort of like an assistant in my eyes. The best example that I can give here is, as a user, if I'm doing something that's automatable, like per se, my girlfriend recently has been applying to a bunch of PhD programs. And what that means is she has to input the same data to 28 different schools or 25 different schools. There should be a moment where web agents can live naively on our desktops, on our computers, to be able to recognize, oh, there's a pattern that I detect here, and I think I can understand the rules of this pattern. So I'm gonna give the user a ping and say, hey, I think I understand what to do. Would you like me to take control? And I think those 2 modes are gonna be very interesting. One where it's in the background and it's connective tissue, similar to an API, and another where it's an assistant that lives next to you and you can give control back and forth.
I love that. Thanks so much for sharing.
Pleasure.
So where can people go to find out more about you and your work?
Yeah, great. So we have a lot of blog posts about our work. Check out Amazon Science and check out if you just Google Amazon Nova Act, I'm sure you will be able to find a bunch of blog posts about our work, about our lab, about our ethos, and types of roles that we got available. The most interesting thing about our lab, the AGI SF lab, is that this was a lot of people that was brought over from Adept, an AI startup that was created by David Luan, one of the VP of Eng at OpenAI back in its initial days. It's filled with amazing people. But the important thing is, we are an organization of just 150 people. Less than 40 of us are researchers. And what that means is everyone's member of technical staff. We have no bureaucracy. It's very flat and it's a very bottom-up culture. What that allows is young, ambitious people and seasoned tech leads to be able to come and sprint as fast as possible. We basically still operate like a startup, with Amazon's resources and all its might. And that combination has been just like a blast. So highly recommend any researcher or any sort of like student at the moment to be that wants to be in a high-paced environment with brilliant, humble, smart people to come check us out.
Amazing. Well, thanks so much, Deniz. Great
Pleasure.
to chat.
Pleasure. Thank you.